All right, welcome back to Module 3 of developing cross-platform development with Xamarin and Visual Studio. I'm Brian Sherwin, and I'm here with Mark Artega, and we're going to jump right into Module 3.
All right, so welcome back, everybody. Thanks for joining us again. So in the last module, we built out an iOS application for heritage properties to list them on a list view, on a map view, and show the details to navigate back and forth. In this one, we're going to do the exact same thing, but on Android and using Xamarin to get things going. So as a quick overview, what we're going to do is we're going to get a Xamarin Android application working. We're going to go through how it works, how Xamarin Android works, the app lifecycle for Android. Because we already have an existing application on iOS and we have some C# code, we're going to start exploring some code sharing techniques. Then we're going to use list view, intents, map fragments to finish building out a Android application using Xamarin. So again, you're probably familiar with this slide if you've seen some of the other modules, but essentially what we have is we have C#. Xamarin takes your C# and you're able to compile down to native code on iOS and Android and use that same C# code on the Windows platform. Now on the iOS side, you have something called ahead of time compiling or AOT, and it compiles down to native code. And on the Android side, what it uses is JIT compiling. So if you're familiar with C# and .NET Framework, it's the same type of JIT compiling that happens in the .NET Framework. So your C# is compiled to IL and placed in an APK, and then on the device, the IL is compiled down to native code. So it has its own runtime. So it's very similar to the .NET Framework, the way it works.
So this is a little bit different than the iOS model in that now we're building that IL code that's being interpreted when we run it, rather than actually building a completely native code base when we deploy it to the store.
Yes, and essentially what happens there is because you have the restrictions from Apple to only have native application or binary-based applications in the App Store, you have to compile down to native code. And in Android, it's a little bit more free-for-all in that store. So you could submit IL code and then do the compiling on the fly. So now the Android runtime model, the way it works is you're going to have your Android OS, and then you're going to have your APK, which includes your IL code and any resources you have in there. And then wrapped around that is you're going to be your mono VM. So the VM is going to be there to interpret your code, and it's going to be a bridge to the Davlik or ART virtual machine, which is part of Android. And you're going to be using either Davlik or ART depending on what version of Android you're on. But Mono will communicate the interop between the Android VM and your code, so you could get down into native code. So you could access, just like iOS, you could access on Android, you could access Google Play, support libraries, activities, fragments, and you could also do some bindings into Java libraries that are available for Java developers.
Okay, so these native APIs, again, we have the full access to the Android platform with the sensors and all those things that are in our phone, but it's being provided to us through this mono VM, which is that .NET Framework running on a non-Microsoft platform.
Exactly, and what Xamarin does, it provides a bridge into the Java VM, Davlik or ART, and that is what communicates down into the native platform. So, like in iOS, we have application lifecycles and structure in Android also. So again, Android notifies us of all these different states and changes. So when a user uses your application, it's going to go from not running, it's going to come into the foreground, and it's going to go into the active. And potentially, a phone call comes in or they push the home button or anything like that. You're going to get paused, partially obscured, and then you're going to get stopped or backgrounded. So you're going to go into the background. And then from there, you could either go into the not running state, you could get into the restarted state, and go back into the active state. So similar to iOS, a few, the names are a bit different, but essentially the logic is almost the same. So now in activity.cs is where we're going to get our notifications for states, and we have overrides in there, similar to iOS. And these are coming straight from the Java SDK. So it's not something that Xamarin made up in terms of the states or anything like that. So you're going to have your not running, and then you're going to be active. You're going to get on create, on start, on resume. And then you're going to get, if a phone call comes in, you're going to get pause. You're going to get the on pause state. You're going to get backgrounded. You're going to get on stop. And then you're going to get restarted. You're going to get on restart, on start, and then on resume again. And then eventually you may get destroyed. And again, you can't rely on the destroyed method being called.
Right. And one of the things I really like about what Xamarin's done here is that they kept all of the Apple flavor of MVC for when you're doing those iOS applications. And here in the activities, we've kept the activity model. So if you've been doing Android development in Java, you're still following that same familiar activity model, but we're doing it in C#.
Exactly. I mean, I just finished some training a few weeks ago, and one of the developers was a Java developer, but in the enterprise he was writing C#. After the training, he's like, yeah, I'm going to start using Xamarin and C# and start leveraging this skill set because I'm in C# all day. Why not use it for my apps that I release personally? So it's definitely something people should look at if you're in C# and Visual Studio all day. So now one of the things, we have some existing code from the iOS app. So we want to look at some code sharing techniques, so some initial code sharing techniques. So we have, first one is conditional compiles. So conditional compiles, you have an if-def block. Essentially, what you could do is you could enable or disable pieces of code depending on which platform you're on. So on iOS, you have a default one, ___iOS, ___, and I'll show you that. But in Android, you have the same thing. And on the Windows Phone, you have Windows _phone, and then on the full framework, you have the same thing. This is great for when you have subtle differences between the different platforms, but essentially a lot of the code is the same. For example, here we have a database file path property, a getter. So if you notice on the Windows Phone side, it's just one line. On iOS and Android, we have two lines with slightly different implementations. So the doc path is actually the same, but then if you look at the system.io.path, in iOS, we need to put it within the library. So we need to go one directory down into the library and then grab the file name, whereas in Android, you don't need to do that. So when you have these slight differences within the platforms, conditional compiles are a great way to do it. Partial classes are another way to share code. So with partial classes, you could have shared functionality in one code file, and then you have platform-specific functionality in a different code file. For example, on this data model, we have a WP8, datamodel.wp8.cs and datamodel.cs. So what the compiler will do is it will compile it down to one class, even though they're in two separate files. So the compiler is smart enough to know that this is only one class and shouldn't be separated.
So going back to that code share, that the compiler directive that we had before, I would put that property in a separate file like this. Is that?
You could use both. So sometimes what I find with conditional compiles, once it starts getting very big, once you have properties, one or two lines, you could use a conditional compile. But once it starts getting slightly bigger, for example, here in the next slide, we need to get the folders. So getting folders on Windows Phone is different from getting folders on iOS, is different from getting folders on Android, potentially. So we want those different implementations. Sometimes we want to separate it out into different physical files, so it's a little bit more organized. right? If you start having a lot of conditional compiles, your code could get a little bit messy and a little bit harder to maintain.
All right.
But with that, that's where shared projects comes into play. So shared projects, you could create a shared project, file new shared project, and then what it gives you is it shares code between different files. So one of the things, it kind of gives you this context switcher right at the top up here, where you see here. So you could switch between, say, iOS and Android implementations. And this will take into account the conditional compiles. So in the past, it was really hard to do this, but now with shared projects, you could actually switch between what it's going to look like on iOS and what it's going to look like on Android or what it's going to look like on Windows. So in that, so when you switch from Android to iOS, you'll see that it's grayed out and the active code is not grayed out. So that's where the conditional compiles come in. And then in a future module, we'll be doing some shared partial classes with platform-specific implementations on things.
All right.
So how shared projects works is essentially you have a project type, an SH project. And then you have your C# files in there, your image files, your data files, anything like that is in that shared project. And then no assembly is actually produced. The projects that reference it will actually produce an assembly or take that code and produce the assembly for you. So the shared projects don't actually produce anything. So essentially how that works is the iOS, the Android, and the Windows application will share will have a reference to the shared project, and it will pull in once it's compile time. It will pull in those files and compile it into its own assembly.
Okay, so this is different than a portable class library because the code is actually going to be imported into my project and compiled as part of that project, rather than a separate library that will be brought in and that's pre-compiled that each project then just references.
Exactly. So it's definitely a good way to do it. Those are your two options, portable class libraries and shared projects. And we'll go through portable class libraries also.
Okay.
So now we'll hop into our first demo, and we'll just explore the application lifecycle and structure for our Android app. So I'm going to continue with the same project that we did Module 2 in when we built the iOS application. And I'm going to add an Android project. So I'm going to add blank app. See here, Android's already selected. And heritage. I'm going to call it heritageproperty.droid. I'm going to click OK. And you notice here we have our main activity. And what we're going to do is we're going to set some icons in here, just so we could have these available. So you notice we just have a bunch of drawable folders, different DPIs. So we're going to drop it into the resources. And we're going to apply to all items. And now we have all the drawable icons here. And these are just icons that we could set for different resolutions, similar to what we did in iOS, but iOS we had to do it a little bit more manually. We're going to create a shared project. And I'm just going to search it here. And I'm going to call it heritage properties shared. And I'm going to click OK. And here you see we have our shared project, and I'm going to add a shared project reference to both the iOS and the Android. And I'm going to set that up. So right now it's not actually doing anything. It's, it's still empty. So let's go ahead and implement that. So I'm going to copy over some models and some services over. And the model is essentially the same one that we have in iOS. So we are going to delete that from iOS. And the service is slightly different, where we have our conditional compiles. So here you see right now in our context switcher, we are in iOS, and it shows the iOS one, because that conditional compile is defined in our iOS project, and this one is grayed out. So once we get the Android one working, we could show how that is, you could use a context switcher to switch through. So I'm going to delete this service also from the iOS, and I'm going to build just to make sure we're still building.
All right, so we've replaced the files that we had before in our iOS application with these new files that we're going to build out in this module.
Yes, exactly.
Okay.
So and then this way we start sharing our main code across the different platforms and take advantage of what we have already built in the past. So I'm going to set our Android project as our startup project, and I'm going to build that one. I'm just going to change the API level to 17. And set it as startup project, and then try to build that out. Here you see everything gets built. We should be able to see our context switcher now. So now we have iOS and we have the Droid project. So if we click it, you notice how the iOS one gets grayed out. And the slight difference here is with iOS, we are not passing in any parameters, but with Android, we need to pass in a stream. And then depending on which platform we're on, we need to load that document either from a file on iOS or from a stream on Android. So with that, we also need to add our data file into our iOS, or into our Android run. So we're going to go into main activity, and we're actually not going to pass our data file yet. What we're going to do is we're going to go through some of the overrides and the application lifecycle. So we're going to replace this implementation with this one, and right there. So we're going to have our onCreate, we're going to have our onStart, onRestart, onResume, onPause, and onStop. So this is for the activity, all the overrides that are there. I'm going to run this on the device. I'm going to bring that up. And right now, everything's going to build. And it's going to push it out to the device.
All right, so again, we're just going to look at the events that are happening as the application starts, stops, goes to,
exactly,
in and out of focus for the user.
Exactly. So here you see we have the the onCreate, onStart, onResume. And then if I go into the device, I'll just hit the home button, and you'll see we get the on pause, on stop. And then I could restart the application here. And then we get the restart, start, and resume. If we go and kill the application, you see the application stops, but we get no destroyed event. So now with that, you also have a app object that you could implement. So we're going to just implement this class. And this application gives you some more overrides. So it could give you a application-wide onCreate override. So when the application gets created, you could do something in here. For example, if you want to load some state or anything like that from a database, you could do that all from here. So if we run this on the device.
So we have activity events and we have app events.
Application-wide events,
okay.
Yeah. So here you see we get the app created, we get the view created, it's resumed, and then we get the same events as we did last time. So you notice the implementation of the app object is a little bit strange. So you have to implement application, and then you have to do the JNI handle ownership. So this is specific to Java, and it's passing an int pointer. So when your application gets initialized, it passes all this, so you have to implement all this and pass it into the base class. And this is how it essentially communicates into the Java virtual machine.
All right.
So that is application structure for Android. So now we'll switch back over, and we'll look at using a list view. So what the goal is here is we want to show the data in the list view. And of course, we're going to have some data. And then we're going to have a list view, and then a table adapter within that list view. And then the table adapter is going to call some AXML, layouts or anything like that, or you're going to build it through code to actually display something in a list view. So you have some base adapters that are available. So Android gives you a base adapter, and you have a standard array adapter and a generic array adapter. And this could just give you a display like this, which is a single text field or a label that you could display, and you could scroll through the list. You also have cursor adapters. So cursor adapters, you have simple cursor adapters and custom cursor adapters, and this is when you want to display data from a database, from a SQLite database on the device, and it's highly optimized for that. So it'll scroll fast. You don't, if you have a million records to load, you won't definitely want to use the cursor adapter. And then you also have custom adapters. So, and that's what we'll be looking at. We're not going to be using cursor adapters, but we'll look at an array adapter and then a custom adapter in the next demo. So I'm going to switch back over. I'm going to just close everything off. And then I'm going to go into the assets, and I'm just going to copy over some items that we need. So I'm going to copy this raw folder and this layout folder, copy it into our resources. I'm just going to say yes to overwrite. And in the layout, what we've done is, in the resources, what we've done is we've added the data.kml file, and which is the same KML file we're using in the other one, and we're adding it as an Android resource right there. So that's the data that we're going to load up, and then in our main.axml, what we have in here is we have a list view, and this is the XML view. So we have a list view to show our properties, and you can see it in the document outline also. So that was pre-built. That's what I copied over. And we need to load some data up. So let's go in here, and we're going to change the onCreate with this right here. So we're going to set the content view to the main one that we have there. We're going to load the data, and then in load data, basically it's going to do the same thing that iOS does, except we're going to be calling this right here. So let me just try to get it all in screen. So we're going to call this.resource.openRawResource, and this is our data file that we want to open. So that is what we're going to pass into the service. It's going to pass it in as a stream. And then we're just going to find the list, and then we're going to create an array adapter of type heritage properties, and we're going to set the type to simple list item 1 and pass in our collection of property items. So up here we have an error, so we just need to add a using statement. And we could add a breakpoint right here. So everything will get loaded. We'll just make sure. And then we will run it.
So why didn't we put that data.kml file in the shared code library?
So this one, we didn't put it in there because we need to load it up as a resource. So right here you see that we have, give me 1 second. So the resources.openRawResource, we wouldn't have access into that from the shared project.
Okay, so it's how it embeds that data into our resource as it goes. Okay.
Exactly. So here you see everything's loaded. We still get 136 because it's the same file. And we're going to go in and we're just going to hit F5. And now you see we have all our heritage properties. Now the reason it shows the class name is because it just does a toString. And the default implementation for toString is just to give it the full namespace of the class. So we could go in here and we could just add a override toString. And we'll just return this .name. So now at this point, we should be able to see some names on our Android app. So, and there are all the names that we have from the data file. So now to stay, to make the list view the same as iOS, what we want to do is we want to show the name, we want to show the latitude and longitude. So what we've done is when I copied the resources over, there was a layout called Heritage Property List View Layout. And this is going to define our custom layout. So we just have 2 text boxes, or 3 text boxes, because over here we're going to also add the ID of the item. So then we're going to go back, and we're going to copy a heritage property adapter into our project. Now this is a custom adapter that we inherit from base adapter, and it's similar to a UI table view source in iOS. You're going to have some overrides in here to get the count, to get the item ID, and the most important part is this right here, is to get the view. So this will load the view, and it will show the name, the ID, and the format, or not the format, the latitude and longitude. So I'll just run this. we have to do one more change in here. And our load data should be changed to let me just stop that. Heritage property adapter. So I'm just going to load the data in here. And here you'll notice how we, for the adapter, we're setting our custom adapter, heritage property adapter, and we're setting it to the list view. So I can also set a breakpoint. So when it grabs the view, it'll go in there. So one thing, as this compiles, one thing to point out here is you want to reuse views when you're doing using list views. For example, here it's going to send in a null at first. So the first time it's going to be null, so we want to go inflate the resource that we created, which is our heritage property list view layout. So that's the layout that I showed, the AXML file. And then it goes in, it creates it, it's going to set the data properties, and then the second time around, it's going to send in the cached view. So this is for optimization because you don't want to call this inflator all the time, the layout inflator.inflate, because that will slow down your application a bit. So I will run this. And there you see we have a custom layout showing the name, and we're showing the latitude, longitude, and the ID. So that is the second demo of showing list data within a list view on Android. So the next step is we want to use intents. So what exactly are intents? So intents are used with activities so you can navigate between different activities within your app. And you can also use an intent to navigate outside of your app. For example, if you want to send a mail, set an alarm, show maps, or anything like that, you can use an intent and pass parameters into those through those intents to the other applications. And you could also pass parameters from activity to activity to show different data. With that, we'll just switch back over to the demo, and we'll navigate from, we'll create a details page, and we'll navigate from the different states. So I'm going to add a few files that we've pre-built. So I'm going to add the layout file into resources. And our layout is going to be our heritage property detail, and it's just going to lay everything out. So it's similar to the iOS version, what we've done. We got our ID, we got our latitude, longitude, and we got a web view. From here, we need to create a class called heritage property details. Heritage property details. And we're going to implement as this. So here you can see we're setting up, this is our details activity. And what we're going to do is we have a static property in here to get the selected item. Now this is not the best implementation, but we need to pass the object. And essentially, you can't pass objects using intents. You can only pass, say, an int or a string or something like that. So this is one way to get around it. Using in the next module, we'll be doing some MVVM, and we could pass objects using view models, and we could set state in there. So here we're going to set the content to our heritage property details. We're going to set the ID, the latitude, the longitude, the web view, and we're going to set the title within the navigation bar. Now to get this going, we're going to have to call it from mainActivity.cs, and we're going to replace load data with step 2. And essentially here, what we're doing is we're still loading up the properties, we're finding the view, but this is the new piece of code that we're adding. So we have a item click. So when an item click is clicked, we want to set the static property of which item it is, depending on the position. And then we want to set the intent of type heritage property detail, and then we want to start the activity. And that will navigate into the application and go from there. So I'm going to run this.
So this intent is kind of that automatic building of the segue like we were doing in the iOS. We're going down to the new detail.
Pretty much, yeah, but it's not as nice as iOS, I guess. Yeah. So here we got our application running. I'm going to click on one, and now we could see details. So we can navigate. I'm just hitting the back button on my actual device, so we could navigate back and forth. So that is essentially how we use intents. A quick overview on how intents are used. Now for the next demo, or for the next piece, we need to show everything in a map. So now we're going to be looking at using maps within an Android application and using Xamarin. So with Google Maps, on Android, obviously you're going to have Google Maps. And again, you could use Google Maps either in their native mapping application, so you could set an intent and go out to their application, or you can embed a map within your application. And obviously we're going to be embedding the map within our application route. And to create a map, it's fairly straightforward. Map fragment.new instance, and then you add it to your a fragment transaction, you add it to your root layout, and then you commit it. From there, you will get a basic map inside your application, and this is essentially what it's going to look like. Now you have different style maps. You have normal, you have hybrid, you have terrain. And then to add a marker, well, it's fairly simple. Marker, same thing as a push pin. So you create a new marker option, set the latitude, set the longitude, and then set the title and add the marker. One thing to be aware of is the map. There's a map.map property. That property is not ready instantaneously and does take a little bit of time. So you want to do a null reference check for that before you start adding anything into the map. And one thing that we tend to use is we do a task.run, and here you'll see we have a callback, and we just wait, and we keep calling this callback until the map is actually ready. And then once the map is ready, we'll loop, say for example, all the properties, and then we'll add the markers to the map. So now let's go in and actually implement this. Now, one thing, setting up maps is, it's a little bit easy, straightforward to code, but there is an article you definitely want to look at, is obtaining a Google Maps key, a Google Maps API key on the Xamarin developer site. So setting this up is not that it's easy. It just takes a little bit of time. Essentially, what you have to do is you have to get your signing key fingerprint. Then you have to go into the command console. You have to get this string here, right here, this SHA1. And then you have to go into the Google Developer Console, and you have to set your SHA1 key and the name of the application. And as you can see here, I have lots of them because on every computer that you do it, you're going to have a different SHA1 key. So if you're running your application, two things to check for: make sure the key is in your credentials, and make sure your device has a connection to load the map. So
that's per development device that I need to have that API key.
Yes, and then once you go into release mode, you need to add a new one for release mode once you get it into the store. So definitely read this documentation here. We're not going to go through it, but it is available to you if you just search for obtaining a Google Maps API key.
And that's on the Xamarin website?
Yeah, the developer.xamarin.com. You'll be able to find that there. So now, let's get back into here, into our code. And I'm just going to close everything down just to keep it a little bit clean. And we're going to copy again some more files. Just going to pin that. And what we're going to do is we're going to copy this lib folder into our runtime directory here. So we're going to reference some files in there. Add a reference. There's some assemblies. Just going to copy that in here. And here you're going to see we have the Google Play services and the Xamarin.Android support libraries. So these are bindings that we have that Xamarin provides. You could do it from the component store also and just add them from there. But I'm going to add them manually from here, and I'm going to click OK. And what it's going to do is it's actually going to go out and it's going to download a zip file. So in here, you'll notice it's going to download something, and it's going to need this to compile the application. So you notice a little bit of a delay. That's because the download is happening at that point. But now that should be good to go. So we're going to copy also, get rid of this, the Android manifest into the properties, and we're going to overwrite it because we need to set some permissions in here. So you notice here we have a bunch of permissions. So the map service needs internet access. It needs to write to external storage, access network state, and then you need to set the maps permission to receive. It also needs location support, and you're also going to set your API key in here. And this is the API key you get from your Google developer account. So,
and that's all part of that developer document on
yes.
Xamarin. Okay.
Yeah, that's all part of there.
And setting those values in that XML file, we can do that through the properties of the project as well, right?
Yes.
I mean, there's a UI for that.
Yeah, you could definitely do that. So I'll just open that up. And let me close this one. So you notice here in the manifest, all our items are set. There's just quite a few to go through, so it might be faster to do it through XML if you know the XML. But other than that, yeah, you could definitely go through here and you could set different required permissions for your app.
All right, great.
So I'm going to close that off. I'm going to copy the resource files into here. And then this resource file, essentially what we have are these icons. So I'm going to delete these thumb files that get copied automatically. So these are the for the list view, for the to swap between the list view and map view. Those are just different icons at different resolutions that we have. So once that's in there, we need to go back into our main activity, and we want to create a option menu. So we're going to go in here. I'm going to add it at right up here, and so to create an option menu, essentially you're going to override on create option menu, and then you're going to add the menu item. So here you see we add the menu item, we set the icon, and then we want to set show as action only if there's room. So we're only adding one button, so there should be room, and then we go from there. So once that's set, that will create a button on the top right. I'll run that just to show you. Now, once you add the Google Maps access, you may get an error, and this is taking a while to compile, so we may get this error right here. And essentially what we may run out of is heap space as it's compiling using the Java SDK. You notice our icon, it's still trying to do something. And get 100 warnings. Let's try to see down here. So unexpected top level error. So let's try to go in here. The quick fix that I found for this is setting the Java max heap size to 1 gigabyte.
So now this is something that really only happens when you're dealing with a map, right?
Yeah, once I started adding the Google Play services, this is what happens for some reason. So, and I'm sure somebody will probably encounter this because this happens on multiple machines, for me at least.
All right, so it's doing a really big build here. So we're expanding that heap that we're doing the Java build to, so that we can complete it. So right, it looks like we're successful now.
Yeah, it finished.
All right.
And now, yeah, so now it seems to be going.
So if you're doing maps and you find you're having your challenge with your build, remember to go in and try to change that Java heap size on your build.
And it happens on the Mac too, so it's not just a Windows thing.
Okay.
All right, so now the application's loading. You notice we have a new button in the top right. So the button's there. You know, we can still go in. The button doesn't do anything yet. So let's go in and let's implement that button. And right here, so we're going to load the map, and we're going to fix these warnings. So here you'll see we'll load map, map fragment, and then we're going to add it in. So
okay.
So this is essentially how we're going to load the map, and then
so that's how we get the map. And then is that going to put the pins on the map then as well? Or
so this is how we're going to put the pins on the map. So give me 1 second here. So right here, what we have is our map fragment, and we're going to have a load map implementation down here. That's going to go in and it's going to load the map. And we have some helper methods to hide the map, to set the visibility for the list view. And in here is where we have, if you remember in the slide deck, how we need to wait for the map to show up right here. So now that you could see the button in the toolbar or in the navigation bar to swap back and forth, now we're actually going to load the map so we could view a map and get things going there. So we're going to go to, going to set this up. So we're going to load the map here. We're going to set a map, the map fragment. It's going to load it up. We have some helper methods in here to hide the map when we want to swap in and out of the list view. And we want to set the list view visibility over here. Now, the item where, when the option menu is selected, then we want to actually swap things out. So we go in here, we have a switch statement that just looks for the title of the option button item. And then if it's a map view, we want to show into list view. And then if it's a list view, we want to swap it out. So essentially, we're doing the same thing as we're doing in iOS, and we're swapping in and out of list view and map view. So I'm going to run this.
All right, so we've taken that button. What we just did is added the functionality behind that button to make it come alive, and then we can switch back and forth between the lists and the maps.
Yes, exactly.
Right? All right. So let's see that in action.
Yeah, so right now it's just compiling. And there it goes.
And again, big build because we're using the maps.
Yeah, it takes a little bit longer on this at this point. It's almost there. And there it goes. There, so we got the same thing. We'll tap the map button. We'll swap over to the maps. And there you see we have a map. So the next step is now to actually show the pins. So we're going to stop that. And then we're going to change our load map implementation with this right here. So here, what we're going to do is we're going to load the map. If it's null, we're going to create a new instance. Here we're going to do our callback to make sure we have a map item. And then we're going to wire up the map info click. So whenever an item is clicked, it will notify us, and we can set the intent to navigate to the details page. And then we're also going to loop all the properties, all the property items that we have loaded. So I'm going to just fix these up here. So here you see we just looped them, set the position, set the title, and add the marker. And then we have a method called zoom and center on map. So we call the callback, just keep calling it until the map is actually ready. And then we can zoom and center in on the map here. So here again, we just do a task.delay. We want to run on the main UI thread, because we coming from a background thread. And we're just going to loop all the items, and we're going to set the camera update to zoom in on all the items.
Right, so this is what you were talking about, where there's the map may not be ready, so we're just kind of putting that in that callback make sure the map's ready as we go to draw these things out.
Exactly. And one way I found effective is just to create a task, continuously call that task until the map is actually available to us. So here we've ran the application. I'm going to swap over to the map view. You're going to see we're going to have a bunch of push pins, and we are going to tap on one, and we could see the details. Swap over back to the list, and we could see the details in there. So now we have a same application, similar to iOS, on Android, sharing code, and we still have a lot of UI-based code. Not there. Some UI-based code. A lot is specific to Android, a lot specific to iOS that we want to potentially get rid of, and we started using list views and map views and things like that, and intents to navigate between applications. And in the next module, essentially what we'll be looking at is how to minimize a lot of that UI code using Xamarin Forms and sharing even more code than we're doing right now. All
right. So that brings us to the end of Module 3.
Yep.
And in Module 4, like he said, we'll do Xamarin.Forms and actually get even more code reuse out of our code, building a common UI across all the platforms.
Exactly.